Hi, my name is Jose Luis, and in this video, I'm just going to be doing an exercise where I'm going to be writing a set of utility functions that are going to be useful for doing a lot of things like numerical manipulation, generation of numerical series, some string manipulation, some linear algebra, I don't know, a bunch of things, a collection of things. But the whole purpose of this exercise is to illustrate with examples of everything that we have learned so far about making and creating functions. This video is part of a tutorial series about learning how to code in C#, and it's the last video, is an exercise for the section where we have learned functions. So if you're coming from the playlist, if you think you have everything under control, you're welcome to skip this video. Or if you just want to see me doing like a bunch of examples of like applications of functions, then you're welcome to stick around before moving on to the next section. Okay? So I'm going to start with some placeholder examples from what I did in the previous videos. I'm just going to start with a couple of variables and I'm going to add them together, right? And I'm going to add them with a function that I just created that is called addition, and that it takes two numbers and returns the sum of them both. Okay? Similar to this, I could do another function that would be a multiplication function, where it's just basically going to be a function that returns a number, and it's called multiplication, and it takes two numbers as arguments. All right. I could see multiplication, I could be called multiply, and I was discussing in my previous videos how when I teach, I like breaking things down very clearly in like all the steps, even maybe more than I would in when I write real code. So and before when I did sum, I created a variable and I stored the value of the solution and then I returned that result. For this case, because it's just such a simple operation, maybe I wouldn't even bother to create that intermediate variable. And what I would do is I would return directly the result of multiplying these two numbers, right? And then what I could do here is I could say, let me multiply these two numbers together, okay? And multiplication, okay, my keyboard is a little funky today. Multiplication of these two numbers, all right? And here I'm going to do multiplication. If I run this, I have the sum and I have the multiplication of these two numbers, all right? I also explained in the video how I find it very tedious to write console write line all the time. So I could create like a wrapper function or an alias for console write line, which is just basically a function with a shorter name, but the only thing that function does is calling console write line. So what I can do is I can write a new function, and the return type is going to be void because this is not going to give anything back to whoever calls it. And I'm going to call it log, or even I could call it print. Print is a pretty common name in other environments. And this is going to take a string, which is going to be str. And the only thing that this function is going to do is going to call console write line with that same message. So therefore, I can now substitute here and say this could be called print and this could be called print. Interestingly, I get an error here because as you can see, the print function, it only accepts strings as an input. So something that I can do is I can write overloads. I can write functions with the same name, but that take different types of inputs. So for example, I can just copy paste this whole thing and then just change the type here to be, for example, a double, and this is going to be called value, and then I'm going to print this here. And now I can now print all this stuff here. Okay? All right, cool. What are other things that I probably want to do? Well, I showed in my examples how to calculate the length of a circle. So we're just going to do that real quick for the sake of building up our repository of geometric operations. So this is going to return a double, and this is going to be, for example, circle length, and the input is going to be the radius, right? And the return of this, I'm also going to write it inline, okay? This is going to be 2 times math pi times the radius, all right? And actually, when the result is when the result, when the function is so simple, it's just one line of code that returns something, we can actually use this shortcut that is called the arrow operator, where basically what we can do is, like, instead of saving ourselves, instead of having the block and having the return key, what we can do is we can just use this symbol here. We can use the symbol of the arrow and then right here directly what is it that we want to return. Okay, this is just a shortcut. You will see this very often in for people who are just creating very simple functions. Similarly, we can write a very similar function, which is going to be, for example, circle area, right? And here, what is this going to be? Circle area. And what is the sorry, what is the equation for the area of a circle? There you go. It's pi times the radius square. And we could use here, we could use math.power and say, I want to say the square the radius to the power of 2. But for such a simple operation for squaring a number, actually calling a function has like a tiny bit of overhead. It takes like some computational cycles, right? So if you just want to square a value, very often what people do is that they just multiply it by itself. It's easier, it's cheaper from a computational standpoint. So something that we can do here now is I can say, for example, let me define the value of a radius that is going to be 1, and then print to the console circle length is going to be, for example, the value of circle length for the radius. Okay, and now circle area is going to be the value of the calculation of circle area. You see, the length is 6.2883185 tau, and then the area of the circle is pi. Okay, if I were to do the value of 2, these things would change exactly, and now we have the same value for both things. Alrighty. Now, speaking of power, that is an interesting function that we could implement. So let's say that we want to write more mathematical operations, and we want to say, well, I'm going to write a function that is going to be the power, and then we're going to have the base as an input, and we're going to have the exponent as an input as well. And what I would like to do is I would like to write a function that elevates the base to the exponent. How do we do that? Well, it's going to be very easy. What we need to do is we want to, actually it's not that easy now that I'm thinking about it. So the first thing that we need to do is we need to say, well, I'm going to start with a value that is going to be equal to the base. All right. And actually, I don't think I can use the word base here because it's a reserved word. But what I can do is I can use this. When I want to use a name that is reserved as a variable. So imagine I wanted to call a variable the name double. I cannot use that because that's a special word in C# that I cannot use. But what I can do is I can put an @ symbol in front of it, and then that becomes a variable with that name that I can use. So I can use base here, and I can use the @ sign to make sure that even if it's a reserved word, I can use it as a variable. But that's typically not considered good practice. So I'm just going to call it base value so that it's just not confusing. All right. And then how do I elevate a number to an exponent? Well, basically I take that number and I multiply it several times by itself. Okay. So what I can do is I can say, well, if because it's a repetitive operation that I want to do, I can just say, well, let me create a for loop that is going to start at 0, whatever. It's going to be less than the exponent, and it's going to be I++. All right. And then what I'm going to do is every time I every time for each one of these cycles, I'm going to take the current value and I'm going to multiply it by the base value. So I'm going to multiply the result, the accumulated result, over and over again. And then I'm going to return this value. All right? However, I think this is not going to work. Let me try it out. So multiplication, the power is going to be power of a to b. And let's make b 2 to make sure that things are under control. So you can see that 5 squared should be 25, but instead it's 125. That's because since we have this for loop is not correctly designed, because it's going from 0, but it's iterating as many. Hello? Sorry, I dropped the microphone. But it's iterating as many times as the exponent. So, but because I already initialized the base value to base value, then actually I have to iterate one time less. So this should be exponent minus 1. And then if I run this code, now I have the correct value here. But this function is also not entirely great because there is a corner case. So if b is equal, whenever I elevate a number to the value of 0, what is the result that I should get? I should not be getting 5. What I should be getting is the value of 1. Any number elevated to 0, the result is 1. So what that means is that first of all here, I should make a check where I say if exponent equals 0, then what I should do is I should return the value of 1. And then otherwise, execute this code here. One of the interesting things about, and there you go, here. One of the interesting things about the return keyword is that it also, whenever I call it, it also stops executing the function. So after using return, anything that happened afterwards is not going to be executed in that function. So that's why this code here will not be relevant if whenever I return the value of 1. So return is a keyword that is also typically used to exit, to finish a function prematurely and to not keep executing everything that is coming afterwards. All right. Another thing that I could calculate is, for example, functions not always have to work with numerical values or not always have to return numerical values. They can return other things. And a very common type of returning is whether if something is true or false, right? So Booleans are a very typical return value for functions. So for example, an example of that could be if I take these two numbers, I could create a function that compares them, and it tells me whether if one is greater than the other. So for example, here I could write a function and say, this is going to be a function that compares two numbers, tells me if one is greater than the other. So the return value is going to be a Boolean. The function is going to be called is greater than, all right? And then it's going to take A and it's going to take B. And then what I can do is I can either create a variable, I'm going to call greater, and if A is, and I'm going to store the value of A is greater than B, and I can return that. Or I could shorthand that by just not doing the variable, or even by just doing this here. Let me try how that looks like. I'm going to print I'm going to actually write a full message. I'm going to use the $sign to do a string interpolation, and I'm going to say, is the value of 10 greater than the value of B? And then here I'm going to print the result of the function is greater than A and B. Okay, so I'm going to print this here, and you can see is 5 greater than 4? True. I'm going to change the values now. Is 5 greater than 6? False. And what if I do both the same number? Is 5 greater than 5? that is also false because it's not greater than, it's equal to. Okay, so so functions that return Boolean values is a very common thing to do. Okay, now let's do like a little bit of functions that are more like geometry style kind of functions. So for example, let's say that I wanted to calculate the distance between 2 points, right? We know that in order to do that, we use the Pythagorean theorem. Okay, so let's create a function for that. So let's say static, we're going to return a double because it's the distance between points. And let's say that we're going to just do 2D for this one, okay? So what I would want as inputs would be the xy coordinates of the first point and the xy coordinates of the second point. So I'm going to do x0, y0, and then x1 and y1. And then what I need to do here is I just need to calculate the algorithm, so the Pythagorean theorem, and then return the result. So what I'm going to do is I'm going to calculate the horizontal distance between them. So that's going to be dx is going to be x1 minus x0. dy is going to be y1 minus y0. And then the Pythagorean theorem is that the length of the larger side of the triangle is equal to the square root of the sides of the other sides of the triangle squared. All right, so d is going to be equal to math square root. I think I have videos where I've done this before. Dx times dx, so dx squared, plus dy times dy, which is dy squared. And then I can return the result of this. So let's see. So let's, for example, calculate the distance between 2 points. One point is going to be 0, 0, and the other point is going to be 4, 3. And I know that that distance should be 5 because I know that a Pythagorean rectangle of 3, 4, and 5 is a Pythagorean, is a square rectangle. So I'm going to say distance between points 0 and 0 and 4 and 3. And that distance should be print distance between points, and that's going to be dist. So let's see if that's a good result. All right, the distance between points is 5 units. So that's looking good. I'm just going to input 2 other random numbers. I don't even know. And honestly, I don't know if this is true or not, but I think this is going to work. So yes, so that should be 0 and 0. All right. So I do have someone is telling me from the chat that I actually do have a video about that. Maybe it will pop up here on the channel, on the cards, or it will be in the description, or you can just Google in the channel how to calculate the distance between 2 points. All right. Okay, wonderful. Now, going back to the idea that functions can return other things that doesn't have to be numbers. One thing that is interesting is we can calculate, for example, we can calculate if a point is inside of a circle. All right, and the idea is that that's actually quite easy to do. Let me switch to my drawing board. If I have a circle and I know the coordinates of the center and I know the radius, then that circle is perfectly defined, right? And the idea is that I may want to check if a particular point finds itself inside or if it's outside of that circle. The rule is actually quite simple. If I know where is the center of the point of the circle, and I know its radius, then it's just as simple as saying, well, let me calculate the distance from the center to that point. And if that distance is less than the radius, then the point will be inside of the circle. If that distance is longer than the radius, then the point will be outside of the circle. Okay, so it will return true or false. So let's see how would we implement that. I'm going to go back here to the circle, and I'm going to create a new function call, which is going to return a Boolean, true or false, and it's going to be is inside circle. Okay, so and then what I'm going to do is I'm going to create a parameter which is going to be cx, the x coordinate of the center of the circle. Another one that is going to be cy, the y coordinate of the center of the circle. Then r, and then the x and the y coordinates of the point that I want to check. All right. So, okay. So then the first thing that I need to do is I need to calculate the distance between the center of this circle and the point that I'm calculating. Now, what's interesting about this, and this is the power of functions, and this is why they're so useful, is that I could write some code very similar to this one here inside of the function and then calculate the distance between the 2 points. But since I already have that function in my scope, I have created it before, then I can actually reuse that function because functions can call other functions. Just like when I was explaining that a console application indeed is a function that the system executes for you with arguments that are coming from the terminal. And then within this function, we are calling all these other functions. Well, from any function, we can always call any other function so long as they're visible in that scope. So here, what we can say is, I'm going to say this is going to be equal to distance between points. All right, and then the parameters that I'm going to pass is the center, the coordinates of the center of the circle, and the values x and y, which have been given to this function as arguments. All right, so basically, whoever calls this function is going to end up also, as a consequence, calling the other function. And again, this is the magic of functions, the modularity, the reusability, and how linked they can be to each other. All right, and then what I can return is inside. I can create a function, a variable called isInside, which basically tells me if distance, if it's smaller than the radius. And then, I need to get a new keyboard. Sorry. And then I'm going to return this value here, isInside. So let's give it a try. So we have a circle, for example, here. Print isInside circle, and then I'm going to calculate the value. I'm going to calculate the value before. Inside circle, and then here is inside circle, and the circle is going to be, for example, at coordinates 1, 1. All right, the radius is going to be 5, and the point is going to be at coordinates 7, 1. So we can see clearly that because of these coordinates, the point is at 6 units from the center, so this should be false. So let's see if this is false. I'm going to execute this code. Yes, inside of a circle, yes, it's false. And then if I bring it closer, so is inside of the circle? Yes, it's true. Okay, so it looks like our function is working. So we can create geometrical operations also just by taking into account the numerical properties of all these geometrical objects. All right, cool. Shall we do now operations with sequences of numbers? You know, I like those a lot. Let's take a look at those. All right, so let's first create a bunch of functions that perform operations with arrays. Okay, so let's first create an array, and I'm going to call it. I'm going to just create an array from scratch. So I'm going to create an array of numbers, of doubles, and remember that this is the notation that we can use if we just want to give it like a set of initial values right away, without using a for loop or etc. Something that I find very annoying, for example, is that when we use console write line and we want to print all the values of an array, so if I pass an array, instead of printing all the values of that array, what it prints is the signature or the type of that object. It tells me that it's an array of doubles. And I'm actually, just to just to clean things up, I'm just going to cancel this out, okay? So maybe something that I want to do is I want to create yet another override for my printing, which instead of giving me the type of that object, it just has a for loop and it iterates over all the elements and it prints out. It prints them out to the console. So I do this a lot when I do my own coding, for example. I'm going to take an array of doubles, all right, and I'm going to create a print function that just iterates over all of them and it prints them to the console. So very simple. I'm going to say for int equals 0, I is less than values dot, oh my god, I is less than values dot length I plus plus, and then what I'm going to do here is I'm going to console write line each one of those values at I. If I now substitute this with print, then I got a printout of all my values. Okay. Now now things that I can do with this. So for example, in one of the examples in the videos, I showed you how to create a massive addition, how to take an array and add all the values together. So we could create an addition function, which is going to be an overload to the other one that we have, and where we take an array of values, and then we start by starting with a number, which is 0, and then with a for loop, we go over all the values, and we add them incrementally to this variable that we have until we get the result. All right, so for example, mass addition is going to be the result of addition of these numbers. All right, so if I do that, you see that the total addition of these numbers is the value of 30. Okay, all right, now things that we may want to do, a very common operation to do is to calculate the average or the mean of a set of numbers. That is like the basic thing if you do any kind of data science or data visualization. So we may want to create a new function here called average or mean, whatever you want to call it. And I'm going to take it as an input, I'm going to take an array of values. All right. So what are the rules for calculating the average of a set of numbers? What we do is we take all the numbers, we add them together, and then we divide that result by the amount of numbers. Okay? So, like I said before, we could copy paste this code to just calculate the massive addition of all these numbers. But since I already have this function, then I can reuse it and then just say double total is going to be equal to the addition of these values that were given to this function. And then now what I'm going to do is I'm going to calculate the average, which is going to be the total divided by how many elements are in this array. And that's going to be values dot length. And I'm going to return the average. So let's see if that works. I'm going to say mass addition, and this is going to be average, and this is going to be average here. Let's see where we're going with that. Okay. All right. So the average is 6, which kind of makes sense. You see how this number is really, really at the center, right? So if this was, for example, blah, 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 then the average will be much, much off. The average is 2004. Okay. All right. Sounds good. Okay. Now, something that is very interesting is we can use functions to generate arrays as well. And something that is very common to do is to generate numerical sequences by using functions. So for example, let's say that I wanted to create a function that is going to give me a list of numbers from starting at the number that I defined, let me do a diagram of that actually. Let's do a diagram of that. So I'm going to, where am I? Okay, here, I'm going to save this, whatever. And then let's say that I'm going to create a function that is going to say give me a list of 5 values, all right, with starting at 0, for example, or starting at 0, and with the step value being 2 units. If that was the case, then my resulting list, and this is typically referred to as a series, is going to be 0, 2, 4, 6, and 8. Correct? Because the values between them are, the gap between them is the value of 2. So let's take a look at how to implement this here. So what I'm going to do is I'm going to call this function numerical series, and then what I'm going to do is that the first value is going to be the start, and then how many elements is going to be an integer in this case, because I don't want to have like 0.5 elements. And then I'm going to, and actually I may want to do the step value here as a double, and then the last one is going to be count. So how many elements do I have? Now, interestingly, what is the return type of this function going to be? The return type is going to be double, but it's not going to be one single double. It's probably going to be an array of doubles. So in this case, the type is going to be an array of doubles. Because it's C#, I could also choose to return a list of doubles, but it turns out that because I already know from the definition of this function how many elements my array is going to have, I can calculate that very easily here with this value. So arrays are a bit more performative if we know always what we're going to have. So in this case, I'm just going to choose an array. And then what I'm going to do is here, inside of the function, I'm going to define an empty array. I'm going to call it, for example, list. And then it's going to be a new array of doubles with a capacity of count elements. So how many numbers I want to generate. And then I'm going to iterate with a for loop. I'm going to say this is going to be equal to count elements and I++. And then what I'm going to do is I'm going to say for each one of these elements, so for list I, the value of this element needs to be something that relates to this equation, this list that I just expressed here. Oh, I'm a little fussy right now. And the rule is going to be very simple. If this is element in position 0, 1, 2, 3, and 4, the rule is that the value in each one of these positions is where they are, so the index number, plus, so the start number. Oh, I'm going to mess this up, sorry. The starting value, so whether if we start at 0, 10, whatever, plus where they are in the position times the step size. So that looked terrible. I need to adjust this a little better. But I think this is actually much better just seeing here. So this is going to be the start value times where they are in the list, in the first element, second element, third element, times the step size. So if the gap is 2 units, 3 units, 2.5 units, etc. And then we're going to return this list. Let's see if that works. So I'm going to replace here these hard-coded numbers. And what I'm going to do is I'm going to say, I want to create a numerical series which is going to start at 0. I'm going to do the exact same example of the diagram. The step size is going to be 2, and I want to have 5 elements in this list. And let me print that to the console. So I'm getting 0, 2, 4, 6, and 8. That's pretty neat. What if I wanted to start at 10? Then I would get 10, 12, 14, 16, 18. What if I wanted the gap to be 2.5? Then I would get 10, all the way up to 20. All right? Okay. So how is that sounding? How is that looking? Okay, so another way of creating lists of numbers as opposed to what we've done before, which is we chose the starting value, we chose the gap, the step between numbers and how many numbers we wanted. Very often, a very common thing that we want to do is generate lists of numbers where we know where we want to start, where we want to end, and how many intervals do we want between those numbers. This is typically referred to as a range, and the idea is quite simple. Let's imagine the number line, right? And let's imagine that we start, for example, at the value of, I don't know, let's say that we start at the value of 4 and that we want to end at the value of 10. These are the numbers that we want. And we know that we want to divide this interval in 3 steps. So I want a number here and I want a number here at equal intervals. We know that this is going to give us the number 6 and the number 7 here at the center, right? We also know that if we instead we want, for example, 4 intervals, right? So we would probably end up with something like 5.5, 7, 8.5, and 10, all right? And what's interesting is that we need to keep in mind that what we are defining is how many intervals are between, how many steps are between the numbers, then it turns out that the actual number of numbers, the total of those numbers, is 1 unit greater than the number of steps. So if I have 4 steps, I end up with 5 numbers. And if I have 5 numbers, I end up with 6. You know, I'm messing this up too much. Okay? So, so the rule is going to be very simple. For each one of these numbers, the rule that we're going to do is that the number is going to be equal to, the number that we're generating is going to be equal to the start number, so that's going to be this one here, plus where this number is sitting on the list, so this would be 0, 1, 2, 3, and 4, times the gap between them, all right, or the step size. However, we don't really know the step size because the only thing that we know is the number of intervals. But the step is going to be very easy to calculate because the only thing that we need to do is we need to calculate the length of the interval. So that's going to be the end value minus the start value, and divide that by how many steps are in our range. Oops, I'm right there. Okay. So then let's do that with code. So what I'm going to do now is I'm going to say static double new numerical range. And let's say I'm going to define the start of this range, I'm going to define the end of this range, and I'm going to define how many steps I'm going to divide this range in. So now what I would need to do is I would need to calculate the step. So that's going to be the end value minus the start value. And all of that divided by how many steps are on the range. And then it's going to be very easy. I'm just going to create a list of numbers. Is going to be the number of elements for this list is going to be the number of steps that we have plus 1 unit, as we just described in the diagram. And then for int I equals 0, I is less or equal to the number of steps, all right? Or is less than the number of steps plus 1, however you want to see this, it doesn't really matter, right? Or an I++, and, oh, I'm messing this up again. What's going on here? Okay, there you go. And then, so what I'm going to do is for each element of the list, what I want is, I want that value to be equal to the value of the starting point of the range plus I times the step size of this, and then I could just say return the value of the list. And actually, you can see that this list here, this code here is super similar to this one. If you wanted, something that we could do is we could just say because I have the step size now, what I could say is, why don't you just return a numerical series where we also start with the value of start. The step size is that value that we have calculated, and the number of elements is going to be the number of steps plus 1. Okay? Both work exactly the same. So let's try this one, for example, numerical range, and that's going to be from the value of 4 to the value of 10, and we're going to divide this in 4 intervals. Okay? So if I run that, 4, 5.5, 7, 8.5, and 10, just like we had in the example here. And let me show you how this works exactly the same as just calculating the step size and calculating the numerical series using the other function that we already created. So if I run this code, now it should work exactly the same. All right. What's interesting is that we can flip the direction of both by just saying that one has to be a negative number, or even not, maybe not even a negative number. It can just be like a number that is lower than the previous one. So if I do that, you can see that we now have a decreasing range because the end value is smaller than the larger value, than the start value. Okay, so whichever code you feel more, they're both ways work pretty well. Okay. The last example that I would like to do today for this exercise is to create a cool function that you can call, and then that creates like some very nice ASCII art on the screen based on whatever parameters you give it to the function. And if you remember from a previous exercise video on this series, we spent a full exercise just doing ASCII art and writing functions and for loops that created ASCII art. And we even write something that would take input from the user. So for example, I could type in here like 50 characters, wide rectangle, and the height of the rectangle is going to be 30 characters, and then each rectangle would have that size. This looks square because like the form factor of characters is not square. So let me do it again. Let me say 50 and 20, for example, and then you see that now it looks more like a rectangle. But it would be really cool if we were able to create a function that would take two numbers. So for example, the width and the height, and maybe the border radius and the border of this, and create a rectangle with those parameters. So what I'm going to do is I'm basically going to go here, what it says border rectangle. This is the code that we wrote for this is the code that we wrote for creating this second rectangle, the one that is hollow inside that has a border. Okay, and then what we can do is we can just copy this. This comes from the previous video, and then just wrap it inside of a function. This function is going to be a function that is going to draw an empty rectangle. Because what this function is going to do is just going to draw things on the screen. It's not going to compute any numbers or anything. The return value of this function is going to be void. So we don't want to give anything back to the user. All right. And then I'm going to call this function something like draw empty rectangle, and it's going to take some parameters. So for example, it's going to take the width of the rectangle, it's going to take the height of the rectangle, and it's going to take the border width, for example. And my keyboard is doing my keyboard has its own life somehow. And then what I'm going to do here is I'm going to copy paste this, and I'm going to replace a few things. So I'm not going to print this anymore. Now border W is I'm just going to replace all instances of border W with the actual value that we're using, the name that we're using for the function. So that's going to be here, 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 and here. But everything else is going to be the same. Maybe even I'm just going to use a dot here. to draw how the emptiness, all right? And then you can see that now it's just going to be super simple. The only thing that I need to do is in the main code, I just say draw empty rectangle, and can you draw 50 units wide, 20 units height, and for example, four pixels, 4 characters for the width of the rectangle. And if I run this code, I get my ASCII art, I get my big rectangle, 4 units in the border, and then these dots in the center. Yoo-hoo, right? And yeah, and this is actually, yeah, this is quite cool actually. And you know what? Why don't we actually create a console application that we can call from the console? Why don't we create a console application that we can call from the terminal, and we give it the parameters, and then it just prints it to the console? Actually, I think that's a good idea. So I think I'm just going to record another video, and we're going to do that in the next video. So thank you very much. I hope this video was helpful to wrap up and to solidify all the ideas around how to create functions and everything that we have learned in this section. If you like this video, if you like this series, if you want to support the channel, please go ahead and like this video, subscribe to the channel, turn on notifications and all those things. And I guess I'll see you in the next section of this playlist. Thanks a lot.